Hello and welcome to this University of Leicester PG Spotlight session on molecules and materials. My name is Alicia and I'm the UK Postgraduate Recruitment Officer here at the university. I'll also be the host for today's session. My colleague Sam is on hand in the chat function to organise any questions you may have. So please just take a moment to familiarise yourself with the Teams layout. So the chat function is located in the sort of top banner of your screen on the right-hand side. Feel free to say hello, let us know where you're joining from, and perhaps a little bit about what you're looking forward to from today's session. Just so you were aware, I'm joined today by staff from engineering, chemistry, physics and biological sciences, and we're going to be exploring what Master's Study Beyond is like at the University of Leicester. Just so you know, these sessions are being recorded. You will be able to watch them back online shortly after the session, and if there are any other sessions that you've missed throughout this week, you will be able to find those online too. So just to get started, I'm going to hand over to our panel to introduce themselves with their name, perhaps a bit about their role and maybe something interesting about their work or area of research. So Mukund, am I okay to start with you?
Yep, that's fine. Hi, everyone. My name is Dr. Mukund. I represent School of Engineering. I hold the role of Director of Education for the school, looking after all the undergraduate and postgraduate programs. I have joined Leicester 5 years before, mainly to work in the field of manufacturing, and my research interests are in the area of digital technology adoption, digital manufacturing, and optimization. So currently working on projects related to robotics application in manufacturing. So that's my background, and I can pass it on to the next person. I'm happy to talk about all the engineering programs in the school.
That's great. We can hand over. Maybe we'll stick within school. So maybe we'll hand over to Rami next.
Hi, thank you. I'm Dr. Rami Misalam. I've been at the University of Leicester for over 8 years now. I'm currently the program director for the new spacecraft engineering MSc that we're formulating. And I'm also the deputy head of the mechanics of materials group over in engineering. Historically, I've kind of floated around between the School of Engineering and the School of Physics, focusing on research areas such as space nuclear power systems, which is an area that the University of Leicester has been pioneering for the past decade now. And I'll be happy to talk about not only the new program we're starting at the School of Engineering, but also the exciting research that we're doing between both the School of Engineering and Physics.
That's lovely. Thank you, Rami. And then Nigel, I'll hand over to you.
Hi, I'm Nigel Bannister. So I work in the School of Physics and Astronomy. I'm based at Space Park Leicester, and I'm actually responsible for the skills development program at Space Park. So I trained as an astronomer, as an astrophysicist, and then moved into space instrumentation development. And so now most of my work is on the development of missions, mission concepts, and I'm a co-investigator on the ESA JUICE mission to Jupiter, which was launched about 6 weeks ago now. And so these are sort of topics that we introduce into our teaching and use those professional experiences in the way that we deliver teaching and skills to our students.
Thank you, Nigel, and we'll definitely be hearing a bit more from you on tomorrow's session as well on Space Pioneer. I'm sure we can find out a lot more about you then. Ian, I'll hand over to you next.
All right, so I'm from the Department of Molecular and Cell Biology, which is part of the School of Biological Sciences. I have a chair in biochemistry. So I run a lab where the research is focused on the splicing of RNA and the molecular mechanisms of that. And in fact, I run a sort of a little consortium, a multidisciplinary consortium funded by the BBSRC, where we have contributors from chemistry in Leicester. Somebody else is a structural biologist from my department, and then colleagues from synthetic chemistry and engineering from Strathclyde and Glasgow. So this is a very multidisciplinary little group, and so the research we do focuses on using the methods that enable us to look at single molecules, particularly during splicing reactions. But I've also done some work relating to therapeutic approaches to manipulate splicing, as a strategy for overcoming particularly some genetic diseases. And so we're quite heavily engaged in that area as well.
That's great. Thanks, Ian. And over to you, Richard.
Hi, I'm Richard Doveston. I'm a lecturer in chemical biology within the School of Chemistry, and one of my main roles there is to look after our chemistry MSc program, which has been running for the last couple of years. I also teach a lot into the organic chemistry and our medicinal chemistry undergraduate programs. In terms of my research, I actually sit on the interface between chemistry and the life sciences. So I was in the same building as Ian. My lab's just behind me, and we're part of the Leicester Institute of Structural Chemical Biology. And my group's particular interested is in developing small molecules as drugs that work in new and different ways that might circumvent challenges arising from resistance in cancer or antimicrobial resistance and those kinds of challenges.
That's super. Thanks, Richard. And I will declare a small conflict of interest that Richard was my PhD supervisor. So we won't hijack the session talking about PPIs for the duration of the hour. I promise you that. So just to kind of start things off, I guess, for the people sort of in attendance today, they might be interested in the research themes, topics or areas that recent master's students have maybe been looking into. So maybe some key dissertation topics that have been taking place. Does anyone have any sort of examples to hand that they'd like to share to sort of kick things off? Perhaps if we go to engineering, I don't know if there's a representative that'd like to start.
I think I can go first on that.
Yeah.
So the School of Engineering offers 6 programs in PGT, which is postgraduate. So one of our flagship programs is called as Masters in Engineering Management. Then we offer programs in mechanical engineering, aerospace engineering, and electrical engineering. And all the modules are research-based or research influenced, where the academic staffs talk about and teach the students about the research activities that are taking place in their labs or through their research projects. And at the end of the 2 semesters of taught modules, students are exposed to a dissertation, which is equivalent to 3 months of activity, where students would be embarking on the journey of research through some small projects, which could be through project partners, which could be some industries or through other universities. And the school is very supportive of the students to involve in such research projects, because it's not only about doing research, but also developing skills, which, as Nige mentioned earlier, professional development skills of proper teamwork, presentation skills, communication, all that is something that employers in the future are looking for, and you are able to gain that exposure through your projects. And something that from an engineering perspective, we all want all the engineers of the future to be T-skill shape focused, where you go deeper into one discipline, but have a wider understanding of topics from other disciplines. So multidisciplinary or interdisciplinary type of projects are encouraged by the students. And many students do publish papers out of their project, but again, that is an opportunity for students who want to do a PhD after this. This could be a platform for you to test whether you like research, or whether that's the direction you want to go through, and the university and the school and the staff provides you that support. And with respect to research in engineering, the research ranges from materials to space. So everything under engineering is being covered. So we have 7 research groups in the school, starting with biomedical engineering, fluid mechanics engineering, aerospace engineering, and then Rami and Nige looking at the spacecraft engineering, and then materials engineering. So there are 7 research groups that are involved in the school activity. So each academic staff are aligned to these research groups, and each research groups will be delivering some modules as part of your programs. And that is where you are given the choice to choose any of these areas of research when you want to work on your dissertation. So we expect the students to find out topics that would be interesting for them to build their careers. I mean, these projects will feed into your job applications and everything. For example, one of my recent graduate from the engineering management program, the student wanted to focus on green hydrogen and mainly wanted to focus on the management issues of implementation of green hydrogen with respect to the logistics side of things. So at the end of the project, at the end of 3 months of the project, when the student went for an interview to a very big multinational company, I can name the company Honeywell, the whole presentation during the interview was about the dissertation, and the student was able to impress the employer through the work done and the ability of translating the knowledge that student gained during those dissertation was very vital for the student to secure a job at the end of the studies. Now that student is coming to campus to recruit people. So that is where, as academician, we feel very satisfied that the project that student has done has helped them to land on a job, and now they are becoming citizens of change for the university by involving their expertise to help the students of the future when they enroll with us. So there are so many other examples, but I just wanted to say how master dissertation can land you into a job, and that is where the opportunity for students to engage with external partners and also talk about something in your dissertation. It's not only the 8 modules you study, but it's about the skills that you gain during this dissertation will enhance your profile even better.
Absolutely. Yeah, absolutely, Mukund. Thank you. And I think we will sort of talk about some of those additional skills a little bit later on in the session, actually. So we can definitely draw back to that. Richard, did you want to maybe talk about some of the research themes or topics within the chemistry MSc program? I know we're sort of split between a couple of different options within those courses.
Yeah, sure. So, well, our chemistry MSc was redesigned really to be research focused. So it's unusual in the UK in that our research project is 90 credits, which might not mean very much to you, but it effectively means half of your MSc is undertaking your research project. So it involves being embedded in a research group within the team for a full 8 months, conducting independent research, of course, under the supervision of one of our academic members of staff. The other really good thing about our course, I think, is that you get a bit of choice as to where you do that research. So you might be embedded in one of our themes, which might be chemical biology, sustainable synthesis and catalysis, spectroscopy, atmospheric chemistry, and materials and interfaces. So just a few examples of the projects we've got going on at the minute. One of our MSc students is in our materials centre working with Andy Abbott, developing new ways to extract precious metals from technologies, so particularly lithium-ion batteries and how we can recover the precious materials within them. We have a student in Ramasund Thuralingham's lab developing copper complexes to kill cancer stem cells. And we have a student in Alison Stewart's lab developing medicinal chemistry approaches to introduce fluorine into drug molecules. So a really broad spectrum of projects going on. We also have some activity at the Space Park Leicester through our atmospheric chemistry group, looking at air quality and different things there. So we really do, students choose a wide range of topics, and we try and place them as best we can so that their research projects match up with their interests. And of course, as Mukund alluded to, a good project that excites you and interests you can really land you a good job if you can show you've got the right skill set and background knowledge moving forward.
Absolutely, yeah. And like I said, we will unpick some of those sort of other skills as well very shortly. So, Ian, I just wanted to give you the chance if you maybe had any research topics or themes that maybe you wanted to share from your school.
Yeah. So this department is responsible really for two main MSc courses. One is in cancer cell and molecular biology, and the other one is in bioinformatics, which is a program that's actually shared with the genetics department. So that spans the two departments. In both cases, roughly the first term is spent on sort of formal education. That is to say, in the case of bioinformatics, learning programming and how to handle appropriate databases. And in the case of the cancer cell and molecular biology, it's about the sort of basic cellular mechanisms of cancer. But then following that, people go into the research labs, and there they will spend, I think, about 5 months doing laboratory work, followed by writing up their dissertations. They're not, I think, very different from the other MSCs. So you have a choice of roundabout, in the case of bioinformatics, about 20 to 30, varies from year to year, projects from which you can choose, and something around about the same for the cancer cell and molecular biology. So many of the groups in this department will take MSc students in, just once, usually one student per group, into their research lab, and then they become part of the research lab. They work alongside the PhD students and the postdocs, and they get a very thorough grounding in the research that's going on. So to give you an example of some of the types of project, I mean, I'll perhaps deal with students that have worked in my lab later on, perhaps under another sort of heading to do with career outcomes and so on. But under the cancer cell and molecular biology area, then I've got a list here of last year's projects, and these varied from creating a zebrafish model of human disease through to looking at particular proteins, again implicated in cancer and their interactions with other proteins or with small molecules. There's a project here about how viruses avoid therapeutics and vaccines. There's a project about senescence, how to say the way that cells die and the products they secrete which trigger responses in other cells around them. So quite a wide range of sort of biological areas relating to cancer. And in the context of bioinformatics, the range of projects is absolutely enormous because many people in the school use bioinformatics and apply it to their basic research. So the bottom of the list I've got here, project number 23, is identifying the genetic causes of bicuspid aortic valve disease, which clearly involves the collection of very large reams of data regarding genetic variants, people who've suffered from disease, from patients and controls. Or another one I've got here is looking at the methylation profiles of particular promoters in cancer cells. Another one here is about drug development, how you use protein structure to model drugs that were likely to inhibit that particular protein's function, and so on and so on. Another one perhaps about classification of bacteriophages. Such an enormous diversity of projects, and you can choose whichever one you feel is most appealing. So it's a great opportunity to pursue any area that you're interested in.
Absolutely. I feel like amongst the group, we've kind of already touched upon the fact that there's such a wide range of directions you can take this in. So actually your MSc, and this is something we spoke about in a previous session, is that it's your MSc in your way, shaped by what you're interested in and perhaps what you want to go into in the future. I don't know if Nigel or Rami, you guys wanted to add anything onto that, maybe with students that you've supervised recently or been involved with.
Yeah, so maybe I can say something about this and the relationship, I suppose, between the projects and the wider work of the schools. So the spaceflight engineering MSc is a new MSc, but it's a new MSc coming from a university with a very extensive heritage in this area. And I just want to give you an example of the kind of project that is likely to be issued. We're a center that produces technologies that form the heart of future missions. So I suspect strongly that Rami is going to say something about space power shortly, and we're involved with a really exciting mission that is using a design that was developed at the University of Leicester for very high resolution astronomical analysis. And one of the key requirements for that mission is an extraordinary level of spacecraft stability, attitude control, attitude sensing. And these are precisely the kind of problems that make really good MSc projects. The projects that we're offering and incorporating into the program are not projects that are done because we need to find a project for students to do. They're projects for which there is a very interested and invested stakeholder. So in the case of the astrophysics mission, there are stakeholders in a number of scientific research organizations, engineering research organizations, and so on. So these are projects that could lead to genuinely valuable outputs for both the student in the sense of demonstrating their competence, but also to deliver to an external partner, and you can put that in your CV. It has a very meaningful impact on your career development. The other point that I wanted to come back to was the point that Mukund made about sort of skills and behaviors. So one of the other roles that I play nationally is as the academic lead for a group of space industry. So these are space engineering companies, including all of the big ones that everyone will have heard of. And for those companies, for those employers, it's really clear that technical skills, technical knowledge, of course, really important. But one of the points that they consistently remark on is the challenge of recruiting students from university who have not only the knowledge, but have the behaviors, that understand how they're expected to behave, to work, the discipline that they have to show, the commitment that they have to show in the workplace. And so the projects in the MSc Spaceflight Engineering course are designed to instill that working discipline, the work ethic, and the professional behaviors that employers really, really want to see.
Yeah, absolutely. I think maybe this is a good time to start talking about how, what that skills development from all of the courses that you're sort of talking about. So I don't know if, Richard, you wanted to kind of bring in directions of future students, and we can maybe start talking about those graduate outcomes and what are the next steps are perhaps after doing an MSc that Nigel's just sort of mentioned.
Yeah, sure. So a good proportion of our MSc students go on to do further research through a PhD, which is really pleasing. The course was designed to prepare people for research. So one student from last year is already in post. It's still in the school here in Leicester doing his PhD in atmospheric chemistry. And two other students have gone away and got jobs in industry for a year while they find the position that's right for them. Other students have moved into education and gone on to do a postgraduate certificate in secondary education and taken that route. But really with chemistry, what we find is students have the skill set to problem solve, which can be sort of applied to many different areas, including finance. So a broad spectrum, but predominantly people stick to research-based roles.
Yeah, that's great. And maybe Rami or Ian, did you want to come in and talk maybe about some of those outcomes, perhaps?
I could talk. Well, I think I'd like to talk about this actually in the context of the four students I've had recently through my lab in the last few years, because I think they illustrate, as it were, a general point as well as a specific one. So I had therefore 4 MSc students working in my lab. One was a bioinformatics student. And you must remember when thinking about bioinformatics that if you study bioinformatics nowadays, then the world is your oyster. There is an enormous demand for bioinformatics students. But this one, like the others, actually obtained, because of his MSc, his dream job, his dream post. And that was to go to a very prestigious lab in Germany, one of the leaders in the field of bioinformatics, and to study for a PhD there. So that's the bioinformatics student. Of the other 3, they came through the cancer cell and molecular biology course, and they also obtained their ideal posts. So one went on to do a PhD in Cambridge. Another is doing a PhD in Singapore, which is where she came from, and it enabled her to get into the right institution there and to get the perfect place. And the 4th one was an American who really wanted, in the end, to go to medical school. And so doing the MSc project here actually provided him with a really prestigious leg up when it came to getting into an American medical school, because he was that much more mature. He knew much more than the other applicants to medical school. He could, as it were, break the barrier and get through.
Yeah.
So they were all 4 very pleased with their time here.
No, that's really great. And I think it just shows that actually by going on to do postgraduate study, it doesn't necessarily put you into any sort of boxes or shape you in one specific direction. Actually, these are people who are taking on very similar courses within similar schools and similar subjects, but actually then all going on to different outcomes. And so it's definitely always worth saying that a master's degree can often open as many doors for you, really. And maybe Rami, if you wanted to come in and talk about a few of those.
Absolutely. Just adding to that statement you said about opening doors. So as Nigel was discussing, we like to focus the projects on areas of research that is currently being built at the University of Leicester related to space missions and space concepts. And because we do it in such a way as to link them, the work that comes from those students are then presented on the international stage at well-established conferences to well-established people over at space agencies and international partners. And so it kind of showcases their abilities on the international stage right from the early onset. And that's a great way to get started as an early career person.
Definitely. I think, again, something else we're taking from this conversation is that ability to then take your skills and transfer them internationally, use your skills from an international basis and bring them to Leicester. So actually, it's very much a two-way street with that. I guess then talking maybe more broadly about those additional sort of things that you get alongside your program. So obviously we've touched upon research and we have touched upon teaching, but in terms of things like perhaps field trips, symposiums, external networking events, maybe other opportunities, does anyone have any really great shining examples of cases where they put their postgraduate students on a sort of a platform to allow them to develop other skills? I don't know who'd like to take that question.
I can go for that because we just recently finished. We took all our PGT students to a lab or a industry tour to Triumph Motorcycles, where the students were exposed to the production line, the materials, the material characterization, and then talk about supply chain. So students from all the backgrounds were able to appreciate what is happening and how their learning is put into practice. So it was a full day visit where students were also given opportunity to present their dissertations to the industry people. And apart from that, as Rami mentioned, we also encourage students to participate in conferences. Again, it should come from the students. It's about how they want to use the opportunity to use their project to explore further. And there are several platforms where we also allow students to go for poster presentations that are organized within the university or outside the university. So school provides support financially as well as mentoring of these students to take part in these activities. So there are modules which will also be linked to any industry trip. So I have several industry trips of going to local industries as part of their modules for data collection. So in with respect to aerospace engineering, students have an opportunity to go to Cranfield for flight simulation, where they really go on a real flight, collect data, and then use the data for analysis. So there could be several opportunities based on the program and the modules they choose for them to get exposed to what is happening in the industry and the real world.
Yeah, definitely. I think that's really great to see those ties with industry. I think within your field as well, that's something that I'm asked often in this role is, what are those links and how does the University of Leicester support and nurture those so that when you have finished your qualification, unless you're looking maybe towards further study, if you are looking to work in an industry, having that hands-on, those skills that Nigel was alluding to, it is really beneficial. So that's really, really great. And I think maybe something that I can relate to when I was kind of in postgraduate study myself is that, and Richard maybe will talk about this, is our external seminar program that's operated at the University of Leicester within the School of Chemistry. I think that was a really, again, a useful point to engage with other institutions, to engage with research in different ways. Maybe Richard, you wanted to expand on that a bit more.
Yeah, sure. Certainly within chemistry, because students' research projects are so long, and in depth. They have the opportunity to take part in those seminars that Alicia mentioned. So we have weekly seminars from external speakers throughout the year. There's always an opportunity for students to go along and share a cup of tea and coffee and talk with the external speaker, or indeed have the opportunity to sit down one-on-one if there's real research relevance or interest there to have a discussion, which is great. Speaking about my research in particular, students who come over to this building or are part of the Institute of Structural and Chemical Biology also buy into the great seminar series we have up there as well. So they get double for their money, if you like. Another thing we've just started in the School of Chemistry over the last couple of years is to run a postgraduate research symposium. I know that happens in other departments and schools already. But the timing of that is deliberate so that our MSc students can join in with that day, present their work, learn about all the other work going on around them, and ask questions and learn in a friendly environment as well. We've always sent our MSc students off to conferences because their projects run over the summer. It's conference season. There are usually plenty of opportunities to go and visit a conference and get that experience of what it's like to be part of it, and perhaps even help present a poster alongside a PhD student they're working with or something like that. So we really encourage that as well.
Yeah, that's great. I could see Rami nodding along as well. Rami, did you want to kind of come in with some insight there as well?
Just thinking of some examples about master students helping out PhD students on their research topics and helping them increase that depth of research that they're working towards. So bringing the topic towards materials. So, you know, as part of the Space Nuclear Power Program we've been running at the University of Leicester for ESA, we've been extensively working on new types of functional materials. And sometimes we do interesting tests with these functional materials, like sticking them in a nuclear reactor and understanding how they behave. And so some of the characterizations that are done on those materials, sometimes we get master students to do those as part of their project work. And that gives them a great insight into some of the new kind of techniques that are being pushed in the field of research, and allows them to kind of get the skill set they need if they want to pursue that pathway into academic research, or also gives them the skill sets needed to really stand out amongst the crowd when going into an interview for an industry role.
Definitely. And I think actually something I'm kind of picking up on throughout doing these sessions is that real sense of community that, you know, when you're doing your masters, you are integrated as part of that more sort of research-based community. You are there supported by my PhD students and staff members within the department. It can be quite a different experience from your undergraduate programs, and I think that's something that, again, I'm often asked about, is those really key and core differences between undergraduate study and postgraduate study, which are very reasonable. I don't know if maybe Ian or Nigel, you wanted to maybe talk about any experiences you might have had with any teaching that you do and the differences that you find between undergraduate and postgraduate study.
Well, I can kick off. So actually, there's almost no similarity. I mean, it's a really very different experience.
Yes.
The start, the postgraduate groups are much smaller, and they're being taught in a different way. I mean, they're not being taught so much as undergraduates are, with a core set of facts that they need to learn, but the emphasis is much more on the skills. So particularly in the cancer cell and molecular biology, much of the first term, as well the training term, is occupied by lab work. And so they are working in the labs under supervision, admittedly, in a class setting, but they are learning some of the very basic methods, pretty much all the time. And they're expected to develop an understanding of these methods and how they can be applied. But then when they finish that, and they then go into the individual research labs, they then become part of the team. I mean, they are, you know, there's me and the postdocs and the PhD students and the MSc student. And this is the little team, and they're just simply caught up into that team and the objectives of the group. And it's through this that they now learn all the new ideas and the new skills that are just on the horizon. You know, I will talk about papers, or perhaps about new methods that have only just been published and have appeared. And in this way, they get some idea of what's going on in the bigger and wider world outside the lab. But the important point is that they feel they're contributing, and that they do contribute, sometimes in an extremely good way. very useful way, to the objectives of the lab, and we appreciate that. And so we bring them on as lab members for their time they spend in the lab with us. Nigel, do you want to take over?
Yeah, I think our experience is very much in line with yours. The difference between undergraduate and the postgraduate taught experience is significant. So, we really look at our projects as being like the sort of the opening months of a PhD. And the transition is really quite clear, and you can see it on the faces of the students actually when they arrive, having completed their undergraduate program, and they're confronted with what is essentially a professional working environment, being set problems that are not necessarily problems that we already have the answers to. Going back to what I was talking about earlier, we're setting the projects because they're fantastic activities to develop the knowledge, but also the skills and behaviors. But we're setting them because there's a genuine interest in these technological questions, and seeing students deal with that change in perspective. When you're given a problem as an undergraduate, you're given a set of starting conditions. You know exactly what problem you have to solve, and you probably know what the techniques and the relationships to solve them are, because it's part of that module, right? So, okay, it must be one of those relationships because we're in module 352 or whatever. With the postgraduate projects, it's entirely different. It's like the kind of environment that you would be in if you were doing a spacecraft engineering role in Airbus. You're given a problem. Okay, we need to find a way to design this spacecraft to behave such that it points in a particular direction for a particular time with a particular stability. Okay, go away and do it. You figure out what are the key technologies that are appropriate. How do I actually model this? I'm not going to get it from a worked example in a textbook because nobody's ever done a mission like this with this kind of subsystem. So it's that transition from learning the basic facts to being able to not just apply them in creative and new ways, but also understanding how to deal with the situation if there isn't a textbook that tells you how to do that problem. Yeah. So working on those new technologies, figuring out ways to model, to simulate, to test whether your ideas are actually valid. A totally different experience to what they get at undergraduate. But those experiences are what makes the basis of a really powerful interview with an employer. When you go to the employer and they want to know what you did in your project, you can talk about your role, your professional role, how you applied management practices, how you applied the industry standards to those problems, and talk with the employer almost as if you sort of worked with their team and knew the language that they speak, which you do because that's what you develop in the postgraduate project.
Definitely, these are huge growth phases, I think, compared to maybe undergraduate study that most of our attendees or viewers will have perhaps been exposed to before. And I guess, Richard, it's probably maybe similar within that chemistry setting as well, with such a large lab component being part of the course. Again, it's that growth phase, it's that development of skills that really takes you there with your master's program.
Yeah, definitely. I mean, I agree completely what everyone said, but what I would say is that there is a process here of development. It's not a sudden thing. So Ian alluded to sort of a training phase. Although our project is very long, the chemistry MSc also has that training phase where students are in the lab learning those core skills, but also the sort of background research skills, being able to interrogate the literature and mine the data that they need, how to manage their reference lists, how to present work, scientific writing. All these things are built into the course. And just as kind of an anecdotal illustration of how effective it can be, at the start of our course in the skills module, students do a literature review on a topic and give a short 5-minute presentation about it. And that's in the first semester, and students are always very nervous and perhaps struggle to think about how to present the information that they have gathered. And then if you compare those presentations to their final presentations, their research projects, it really is amazing how much those students have developed and become independent learners. They learn independently and also design experiments. They become experimentalists, and that really becomes clear.
Absolutely, no, that's really great, and I think it's nice when we're running these sessions and actually from different schools we're almost singing off the same singing off the same hymn sheet, which is really great.
Yeah,
yeah, absolutely, Rami. No, go for it.
Just something that, in my perspective, is really fundamental is the idea that when you're working on something that's so new and hasn't been done before, the idea that you may not come to a solution, and being comfortable with that. Okay, I may not find the solution to this problem, but the journey that you've taken and the research that you've gone into and the learning you've taken from that will help the next person to try and attempt to find a solution. And that's research, right? And being comfortable with that idea that there isn't always a solution immediately is really important.
Yeah, no, thank you. Thanks for sharing that. I think what we'll do is we'll maybe move the session on slightly, just to a couple more questions. I'll also invite people who are in attendance today as well to submit questions onto the chat if they would like to ask anything. We have had a couple come through, which we'll touch upon towards the end. But really, this is just a quick snapshot. I know that we've talked about some of the courses in detail already, but are there any facilities or elements of your program that you think maybe are particularly interesting or particularly unique? I know we maybe have sort of mentioned a couple of these, so take a moment to have a think, but any sort of elements of it that you think really that is such a standout feature for what we're offering here at Leicester. I don't know who'd like to take that first. Obviously, it's quite a big question.
I think Rami should go and promote the spacecraft because it's the best program, because it's linking two schools, and I can talk about MEM because it links School of Business and School of Engineering as well.
That's great. Yeah, Rami, did you want to take that first, and then we can head over to you, Mukund?
It is an absolutely great course that we're setting up here, and I think it's one that builds upon the strong heritage of the University of Leicester and showcases fundamentally what Leicester has to offer in terms of this multidisciplinary capability that it's always fostered. So, historically, Leicester has always been contributing to space missions. So for over 60 years, 6 decades, University of Leicester has been contributing to space missions in some way, via instrumentation, spacecraft hardware, so on and so forth. And the kind of expertise and knowledge that has gone into developing those space instrumentation hardware systems has been across the different schools. So has been across physics, engineering, and those expertise have contributed to those particular missions. So just behind me here is the mixed instrument model of the mixed instrument, which is on the Bepi Colombo mission, going over to Mercury as we speak. And the composite tubes on those had a great deal of contribution from the School of Engineering. The design of the actual instrument was from the School of Physics, but that contribution between the two schools really made that possible. So the spacecraft MSc, spacecraft engineering MSc that we're developing is taking the heritage across those both schools. So some of those expertise from physics in the form of some specific modules, the expertise over in engineering in the form of specific modules, and putting those together into one course. So you may have some modules taught by engineering, you may have some modules taught by physics, and it's being able to gather all those expertise and knowledge that's been developed over the years into one course, which is really exciting.
No, that is really exciting. I think, again, something that I'm learning more about is actually those relationships between schools and that ability to really drive new knowledge at the interfaces of some of our research forefront. So, Mukund, did you want to talk a bit about one of your specific courses you said related to business?
The other program that is quite popular, especially for international students within the School of Engineering, is Masters in Engineering Management. So this is a program where 30% of the module is taught by business school, where engineers are taught about finance and accounting and how to do international business, because now the companies are becoming global, and I mean you can easily get products from different parts of the world, and engineers are important. They need to be aware of the challenges that are involved in international business aspects, looking into technological growth. And the program was set up 6 years before, and the main reason to set up this program was because engineers are very good in technical skills, but they don't understand the value of money, the value of time, and those kind of skills are very important for engineers to be taught. And this program was designed by a chief costing engineer of Rolls-Royce 6 years back, and the program has grown from a very small number to a large number because of the popularity of the program. And we don't want to call it like a mini MBA, but it's a mini MBA where engineering skills are taught along with business skills, which is very important for the future. And this program, because of the link with School of Business, students are exposed to different leadership skills and time management skills, and also the financial skills, which are very important. And that's why some of the engineering students choose financial sector after finishing a master's program, because the pay in financial sector may be higher than the engineering sector. So the skills are useful for them to migrate different disciplines. And engineering management is a program that can be useful for students coming from different backgrounds of engineering, either it being chemical engineering to aerospace engineering. So the wide variety of students who come to join our program are coming from different backgrounds, and that allows us to develop interdisciplinary working through our projects that we do. So which is a good skill, because you can't say that I am a mechanical engineer, I will only work with mechanical engineers. When you go to work in the industry, you need to know how electronics work, you need to know how supply chain works. So that is what is being exposed to this program in Masters in Engineering Management. So I think that's something unique for the School of Engineering to offer.
No, that's really great, and yeah, I feel like I'm also learning a lot about the different nuances of each program. So it's a really great thing to have that input from the business school as well, and that exposure to, like you said, to other leadership styles too, which is great. Maybe Ian or Richard, did you guys want to perhaps mention any facilities or elements of your programs that you think are particularly interesting?
Yes, well, I could make a start. Yeah. So I don't think the programs themselves, the sort of basic core MSc program, is particularly interdisciplinary. I mean, cancer cell and molecular biology is essentially molecular biology and some structural biology, and bioinformatics is, of course, the application of computing to so many areas of biology. But what I think is important is that we have here the Institute for Structural and Chemical Biology. So when the students come into the labs, they very often are exposed to an interdisciplinary environment. So people coming, as you'll have gathered, into my lab, actually, whether they like it or not, I think they do like it, they come into contact with chemists, with physicists, with engineers, and they see how all these different skills are applied to a particular area of interest. And I think that's a really important lesson. It's not, I think, something that you acquire so easily elsewhere. Of course, we do have, as you'd expect me to say, excellent facilities, like our single molecule microscopes. There aren't very many departments in the UK where an MSc student can visualize single molecules and their behavior. Or, for example, the cryo-electron microscope, where people are doing cutting-edge structural biology in the department, looking at the structures of big protein complexes. These are very expensive pieces of kit. And again, there aren't very many academic departments in the UK with these bits of equipment. So, we are very well resourced, but I think really it's the interdisciplinary spirit that I would want to emphasize. And this comes across, as Richard said earlier, in our seminar programs. By coming to our seminars, the students will hear about research across all areas of, or a very wide range of areas at any rate, of molecular science. Richard, is that a good lead into you?
Yes, I don't think I can add much more. I think you're spot on. I think Leicester, when it comes to the research, is a really great institution for interdisciplinary research, and the School of Chemistry is no different to engineering, physics, and biological sciences. There is a School of Chemistry which teaches fundamental chemistry, right? But when it comes to research, we're working very closely with engineers, geologists, physicists, and of course biologists like Ian, not to mention the clinicians at hospitals as well on the patient front. So yeah, it really is a crucible of interdisciplinary research, which all our master students get exposure to through their projects.
No, that's really good. And I think we're sort of drawing towards the end of the session now. We have had a question come through, so I do just want to make sure that we answer that, and I don't forget to sort of to put that question out there. And we had a question through about a research group maybe within the School of Engineering that focuses on renewable energy and also automotive engineering. I don't know if
I think I can go for that as well.
Yeah,
So,
maybe just a brief moment on those, and then we will sort of draw the session towards the end.
Yeah, as I said earlier, that we have 7 groups of research, but we have a specific group called Green Energy Technologies and System, which mainly focuses on renewable energy, but renewable energy in building sector, transport sector, industrial sector. And in renewable energy, we have researchers working on solar, wind, tidal and Rami and co working on nuclear, fusion energy. So the application area cannot be exactly automotive, but of course, the skills that they learn through these research can be transferred to different disciplines. But we do have a very heavily focused research group on green energy and technologies, but not a specific group on automotive. But some of the research that happens in materials research is applicable to automotive industry, and the clients would be in automotive industry. So we do have quite a lot of footprint in those sectors as well. So I think that answers Habib's question.
Yeah, that's great. Thank you for answering that. So I'm just going to give you all a moment to have a think about this last one, and it's really just to sum up master's study or postgraduate study more generally at the University of Leicester in 1 or 2 words. I'm going to give you a moment to do that, and whilst we're doing that, I'm going to share a slide on the screen, just so that anyone who is viewing can get a bit more information about kind of what's coming up for the rest of the week, and also some more information about how to get in touch with us. So I'll give you a moment to think about that. But just to our viewers, I wanted to let you know what's next. So there are more of these PG Spotlight sessions taking place throughout this week. You can find out more about other subjects within the University of Leicester as well. And the recordings will be out on YouTube very soon, so you can catch up on any that you've missed or revisit any of the sessions. It's also worth saying that applications for our PGT courses are open. If you are looking to apply for September 2023 entry, please, we recommend that you apply sooner rather than later. You will find all of the information on key deadlines for your application on the course pages, so do make sure you find out those dates so that you don't miss the deadlines. On those course pages as well, you can find out entry requirements, information and links to funding and scholarship opportunities. So again, if you scan the QR code on the right hand side of the page, that will take you to our main postgraduate site, and you can also see other events like this that will be coming up in the future. There's also a search function on that page too, and a button to take you to chatting to our staff and students. So actually, if you click chat to us now, you can send a message to one of our ambassadors. You can find out really what it's like to be a student in Leicester as a city, but also actually on campus as well. There'll be lots of opportunities to ask questions around the subjects too. You'll also find some student blogs on there as well, which will cover lots of other topics such as maybe accommodation, funding, and sort of maybe travel around the UK as well. We do have some webinars available, so please just check out our website for lots more information, and keep in touch with the university if you have questions about your application process. If you are in the stages of applying, please just keep in touch with the admissions tutors if you have got specific questions, especially regarding visa applications or English language teaching programs. So the admissions tutors and the admissions team are the people to kind of get in touch with in those circumstances. So we're going to bring it back to our panel. So just to focus on our last question, if you could sum up postgraduate study or postgraduate culture at the University of Leicester in 1 or 2 words. So does anyone want to kind of kick things off?
I'll go empowering.
Yes, empowering. Richard says empowering. That's great.
So I would say excitement, because it's very exciting to get involved with research. But I'd also say I think the other thing is you really can achieve your dreams. If you're keen, if you're committed, you do well, then you can put yourself exactly where you want to be in the future.
That's great, thank you. And then maybe Nigel, if you wanted to take the floor.
Yeah. Well, I would say, similar vein, it's career enabling. It really is. When I look at, we teach, but we also practice, and in that research and development activity, I go around and I see graduates from our master's programs working in industry, in spaceflight engineering, in agencies. What we do works and it enables careers.
That's great. And then Rami, I'll hand over to you.
I would say impactful, because
Yeah.
the work you do is related to the fundamental research that we're doing at Leicester. So the work you do is for sure impactful.
That's lovely. Thank you. And then Mukund, to finish off with the last sentiment.
I think everyone spoke about studies and everything, so I'll say this is the opportunity for you to make great connections with people from different parts of the world, learning, understanding about different cultures, and that's an opportunity where you build your future based on that. So I think Leicester provides you the opportunity to meet people from different backgrounds, and that will be a lifelong learning that I would also take away as part of your studies.
Definitely. Thank you so much. So the last thing for me to do is just to thank you all for your time. We really appreciate that. And this will be shared widely with our audiences so they can sort of listen back to this and hear all the great things that you've had to say about your courses. So thank you very much for your time today. And thank you to those of you who have joined our webinar. Please, like I said, do keep in touch with us online as you're sort of progressing through your application stages. So yeah, thank you very much and enjoy the rest of your day.
Goodbye.
Thank you. Bye.